All right, so the goal of today's lesson is to design a city, and we're going to do it by construction rather than drawing it. So if you're like freehand drawing, you're missing the point. So we want to construct a city by constructing like parallel streets and stuff like that. And so I'm going to show you how we would construct two parallel lines. Okay. And then I also want to show you how to construct two perpendicular lines. I kind of already did that with the perpendicular bisector, but I'm going to do it from a point on that line. So if you wanted to construct a perpendicular, not necessarily bisector, but a perpendicular segment that goes through a point on the line, and that point on the line might represent like a house on a street or a school or something like that, or some kind of structure. And if we wanted to construct a 90 that goes through that structure, I'll show you how to do that. It's not too hard. It's pretty similar to the one we just did, the perpendicular bisector. And then I will also show you how to, let's write it down here, construct a perpendicular from a point not on a line. So if you have this dot up above a line, how would you construct a perpendicular if you go from that dot through the line? So if you're trying to say you have this structure and you want to go shortest distance from that structure to the street, the line, the shortest distance would be the perpendicular to that street. How, what would that look like? So we'll do those three constructions together, and then I'll get you started on the assignment that you're going to be doing for designing your own city plan, and that'll count as your performance task for this year. All right, so constructing two parallel lines. Here's how it works. I'm going to just draw a line here, and draw a line. And then you can go ahead and draw a line, another line through here. And it can hit it at any angle you want. Draw a line there, hit it at any angle you want. I got to think about this now. I don't want to do this. Maybe you can hit it anywhere you want. I'm going to go ahead and draw it off this other end. If you haven't drawn it yet, so maybe just, it's like basically you're drawing an angle. So we're going to, this is one way to do this. Oops. We can talk about other ways that you might approach this. And as you're creating this little city design, I would like you to go ahead and leave all of your construction little arcs and things in there. Don't erase them. I know it'll look better with them not in it, but I want to see all the work on there. So I want to see that you're constructing. That's how I know you're constructing and not drawing it freehand. Does that make sense? So I want you guys to construct the perpendiculars and the parallels, parallel roads and perpendicular roads, etc. So we're just drawing an angle, and what we're going to do here is swing an arc through this angle. Kind of looks like the markings for, you're going to mark a couple of angles congruent, so just swing an arc through here. So you'll have to pick a distance on your compass. You choose some distance. I just chose that distance away from the vertex, and go ahead and swing an arc there. Okay, so we're just taking our compass point and placing it on where that other arc intersected, the left ray of my angle, and I'm swinging an arc. Now, what needs to happen here is I want to somehow create the same size gap as I have right down here. So I want to create the same size gap that I have down here and copy that up here. So Do you remember how we would measure an angle's gap with just our compass? We're not using a rule or anything, but it's a compass. Do you remember how we did it before? You know, when you're copying an angle. If you remember the copying angle. Okay. So if you take your compass and you're going to place your compass, the little circular clear piece, place it right where I'm placing my compass's point. And then what I want to do is I'm going to measure the gap here between here and right here. So I swung my arc and then I swung another arc. And you could, when you're doing your city plan, you can swing a bunch of arcs. You can make on the bottom of your page, I'll show you when I get there, but draw a line and then draw another line heading on up through the whole page and then swing a bunch of different arcs, a bunch of arcs of the same gap. And what we need to do is measure what this gap is. So we're measuring the angle without using a protractor, but measuring this gap angle. So if you place your clear circle up here on the first place where the arc intersected the ray of the angle, and then you can slide this until the point of this guy matches up with. I think it's a little easier with yours. There it is. So you see that gap right there that I'm measuring? That's the distance between the rays that make up the angle. And I want to copy that gap up above. So you're just taking your compass right here, and most likely you're going to have to change the distance. It's going to be a different distance than what you just swung. So you just swung an arc through that angle right here, and then we swung another one up here, okay, from this point right here. And we're going to just measure the gap from here to here and then copy that here. Okay, I'm just going to take this gap that I just measured from here to here, and I'm going to go move this thing up here and copy that same gap right here, and then connect this dot with this dot. And you could pick a point anywhere along this ray that climbs up here, this ray that's going up. You could pick a point anywhere in there. I just happened to, I picked this point right here. But you could pick a point anywhere along there and copy this. So all that I'm going to do is then just swing a little arc here, and then I'm going to connect. So there's the gap. That's the same gap that I had down here. Just to show you here. This gap right here and this gap up here are exactly the same. So what I'm doing is I'm creating two congruent corresponding angles. Okay, and then if I connect that point right there through that point right there where the two arcs intersected, then I have two parallel lines or two parallel streets. So right here and here I have two parallel lines. Okay, so once again, just to review, I first swung an arc. Go back and do it again here. This is how you're going to start the little project. So I first created an angle, and it was okay to draw the angle with my straight edge, okay? So you can create an angle, whatever size angle you want. And what I did is I swung an arc here, that distance. So I just swung this arc right here. That's what I did first. And then what I did is I just moved up to here, and I swung another arc right here, creating two arcs that were about the same size. And then what I did is I used my compass to measure the gap from there to there. Okay, you see how I measured that gap? And then I copied that gap up here and then connected where these two little arcs intersected with the point that's over on the right here. And I could keep doing this. I could create another one up here, so forth and so on. But what what makes these two lines for sure parallel is the fact that this angle right here, let's call it angle 1, and this angle right here, let's call it angle 2, are congruent, corresponding angles. Okay. So you're going to create your parallel streets in that way. Now, if I wanted to, I could have placed a point farther along up here. I could place a point right here if I wanted to. I could place it anywhere along here. I need to extend this out. You have enough room. I don't know if I can match this. So I could have extended this out right here and done this process again. I could have swung another arc from right here that was the same distance as this arc down here. I swung another arc out here and then measured another one and created multiple parallel lines. So let's go back here. I'll just show you this. So stretch this out to this original one. Move this up here. Let me. Not moving this whole thing down. It's not grouped. Sorry, I'm not gonna be able to do it. Maybe I can. Okay, right there. I could have swung another arc there, and then gone and measured this gap again. Measured this gap again, and then gone up here and created another one. And then I'd have 3 parallel streets.
Is that even possible?
What's that?
Is it even possible
Possible for what?
to do that?
Yeah, because you're still, all that you're doing is like, I can take this, place it right here, let me do it, and then I just stretch this thing out. It's going to go crazy. But you got to loosen this up and just stretch it out to measure that gap. So yeah, you can do it with these. You're just measuring the gap. It's just that you're measuring the gap by loosening this little toggle and then stretching it out or shrinking it out. And then you're kind of sighting it like you would like on a rifle, like on a scope or something or like that. So it's like this piece is centered on one of the dots, and then one of these 2 holes from this is centered on the other one. So it's a little tricky with these, but you can do it. Yeah. What's that? I didn't do it just yet. I just went by asking. Okay. So are you guys okay with measuring the gap on these? Okay, because you're going to need to create some parallel streets right in the beginning. We'll do that together, but I want to see the construction. And every one of you will have slightly differently, spaced streets. All right. Here we go. So constructing 2 perpendicular lines. So at a point on a line. So I'd like you just to draw a line segment with your straight edge, not freehand. And then place a dot on that line, just anywhere. It doesn't have to be right in the middle. Actually, I'd prefer it not be right in the middle. Maybe slightly farther left. So say this is a street. We have some post office or something on the street, and we want to create another street perpendicular to that one that goes basically right through the post office, right by it. It wouldn't be literally through it, but right by it. So here's how we would do that. So you got your line segment drawn and a dot on there. Oh, Emily's not here. I need to take attendance here real quick. So we've got our dot just somewhere on that line. Okay, so that could be, and what we want to do is make another street come in that's perpendicular to this, but it's got to go through the dot, not through the middle of this segment like we did with the perpendicular bisector, but through this dot that's off center. Okay, so you guys have any ideas on what I could do to make sure that I get something equidistant from that? This is the one I call the TIE Fighter. Looks like a TIE Fighter. Oops, this is what I want. Alright, so I'll show you why it's called the tripod. So if you place your compass point on that dot, so do that right now. And then stretch out your compass, but don't stretch it out so much that on one side or the other side of the dot it's going to go past the line segment. You should stretch it out, but you don't want to, like if I stretch it out this much and then I go swing an arc over here, see I'm outside, I'm off the line. So stretch it out, but not so much that you're off that. So maybe something like that, that'll work for me. And then you're going to create little wings. One here, and one over here. This is the TIE Fighter in Star Wars. See the TIE Fighter? No? Bad guys have little ones, little wings that kind of happen like this. Where this is the center, this is where Darth Vader is sitting, a little pod in there.
It just reminds me of the destroyed Death Star.
Of the destroyed Death Star. Okay. So, anyways, this is the TIE Fighter one. That's what I call it. So what we're doing is creating an equal distance on each side of that dot. And then we're going to do something very similar to what we did with our perpendicular bisector. So you get the little arc on each side of the dot? Okay, yours are different distances than mine. Then what you do is you take and move this compass point, place it on one wing of the TIE Fighter, and then you're going to stretch this out a bit so that it's over half the distance from the wing to the dot, kind of like with our perpendicular bisector construction. And then we're going to just swing an arc right up here, and then another one. And it's okay if it intersects all the instructions there. Hopefully you're doing this in pencil. So there's another arc there. And guess what I'm going to do next? Just like the perpendicular bisector. Have any guess as to what I might do next?
Hey,
Any guess as to what? Yeah. Okay, just a minute. You know what would I do next here? Yeah, Shane, do you have an idea?
you're going to do the same thing with the other.
Yes. And then you've got it. So do the same thing with the other side. And look at this. You create intersecting arcs directly above and below that dot right there. So if you connect these little intersecting arcs here and here, it should go right through that dot and be perpendicular to the line.
Oh, I did it. It is possible.
Okay, you can go quickly right now. Alright, so if you draw it through, that'd be like creating a street perfectly perpendicular to the post office. I think I might ask you to do something like that on there. Like you have this, or it might even be at the end of a street where that T's. And you want to make sure that that street kind of ends right there. Okay? It's not too bad. We need to review it and go through it one more time, or do you guys get it? Were you able to keep up on this one? Yeah.
Can you go through the last one?
This one right here?
No, exactly.
The parallel line one again?
Yeah.
Yeah, we'll do that again. As a matter of fact, I'm going to do that to get you started on the project. So we'll do it again. We'll just do it together. Okay, one more here. This is one I call the smiley face one. This is smiley face. So it's creating a perpendicular from a point to a line. So draw a line. Place a dot somewhere up here, kind of in the middle, but it doesn't have to be in the middle. But there's this dot. That dot might represent where you're located. Okay, so I'm standing at that green dot, and I want the shortest distance from me to this street right here. The shortest distance from me to that street would be the perpendicular to that street. So here's how you do it. Everybody have their line segment drawn? Yeah. And I got to bring my compass down here. So line segment drawn. Your dot, you have your dot up here, up above it. Take the place of your dot. Here's the deal. Place your compass point on that dot. Compass point on that dot. And then what you're going to do is you're going to swing a little smiley face across this line right here. I got to stretch this thing out. Okay, that'll work. See, I hope I didn't go too far. So stretch it out enough so that it will intersect this segment at two places. And there's the smiley face. See that? And then I'm looking at a bunch of your papers, and you're probably down towards the bottom of the paper, right? Kind of running out of room. So there's a couple different things you can do here. So swing your smiley face first. I see you swing your smiley face. Really good.
Wow.
So you're probably out of room at the bottom of your paper. But make sure that that thing intercepted at 2 places. If it just touches at 1, it won't work. This won't work. So did it hit at 2 places? If not, stretch out your compass and do it again. And then you probably don't have the room. But one thing, if you do have the room, you can put your compass point here and swing an arc down here. And then from the other side, do another one. But if you don't have the room, if you don't have the extendo page, which you don't, what you could also do is go back up here and swing your arc. So just all I'm doing is I'm going to swing an arc up here. Whoa, I didn't mean to change it. It's okay. I can change it as long as I'm consistent. Ignore that down there. So pick some length right here, doesn't matter what. Place your compass point on one end of the smile and then on the other. And you're just going to swing an arc up here. I don't want it to go through my dot though. So maybe I'll switch out. This is going to go right through my, almost to my dot. Guess that's okay. And then come over here and do the same thing from this other end. See how I'm on the other end? So other end of the smiley face. Swing it through there. And then if you just, of course I get to cheat my protractor style ruler here. Oops. So then draw in the line segment. It should go through the arc up here, and then whatever theoretical arcs you have down here that are off your page. Okay, so yeah, it's not actually good enough for in there. Some of you it works, huh? But if you connect those two, you got it. That's the smiley face one, and one above is the TIE Fighter. And then they're all pretty similar. They all have, instead of a half circle, they have little crisscrossing arcs up above the line segment and crisscrossing arcs down below. And when you connect those crisscrossing arcs, you create a right angle. So they're kind of similar, related. So I'm going to have you, and you're going to have to do this in class. So we'll start it today, and then we'll have to finish it because you need these construction tools. There's certain things you can do at home on this. I'll probably have you finish this up and turn it into me Friday. But we're going to start it today in class. I just need you to bring this back tomorrow or Wednesday. Can you do that? So you have 2 choices here. Some students are fine with just doing this on the back and flipping it back and forth. It's kind of convenient. Just do it on the back. If that bugs you, flipping it back and forth, you need to grab a white piece of scratch paper up there.
All right.
Or your own piece of scratch paper. Please don't do lined paper. If you could get white paper, that'd be better. Okay, I'm not sure. Yeah, real quickly. Oh wait, no. The pass isn't here. She's not. Yeah, you gotta wait. It doesn't matter. One at a time. Go one at a time. All right. So let me find a blank page here. Actually, I can do it here. Reset the page. All right. Did you read the instructions there and what we're doing? Why don't you go ahead and read the instructions? Then we'll start this together. This is the designing a city project, and we're going to start on it together.
Wait, we're starting on it together?
Yes, right now.
We're doing it together?
We're going to do a lot of it together now. What's that?
Oh, Genesis, really.
I know. You have to kind of slide it and move. Yeah. You know what? Just the length of that ruler will be enough. Okay. So to start, we're gonna like do step one here. We're actually gonna roll through the first few steps on here pretty quickly, and I'm gonna keep recording this because people who aren't here might need some help with this as well getting started. So it says use a straight edge. You got your straight edge to draw and label a street across your paper. Here's what I'd like you to do is not only try to like at least go the length of your little ruler, but if you guys could just draw this street in black, towards the bottom of that white paper, just maybe do it down towards the bottom, not at the very bottom, but just towards the bottom. So just draw it and label the street. The street needs a name. So when we label it, I guess you can name it A, B, C, D, or 1, 2, 3, but you might want to label it, I don't know, Nye Avenue, Rockland Court, and then Rockland Expressway. Okay. Design a city and so that it's going to be like the hood here. So draw and label a street that intersects the previous street drawn. So here we go. And let's not draw it so that it's like the perfect 90 here, but we're going to draw another street that intersects this one. And so it looks like this. Okay, so something that looks like this, guys. Let it kind of extend it out all the way up your paper. Okay? So if you need to, that little short ruler, you may have to slide it as best you can, but extend it out. Okay, so draw another line here. Another line. I'm going to just label this Euclid Street, I guess. There's Euclid Street. And now I just made Pythagoras Street here. Pythag Street. Pythag Avenue, Euclid Street. Go ahead and label them as you're going. You can name it however you want. You don't need to name it the same as me. So we have one street on the bottom, another one intersects, and you can hit it at any angle, it doesn't matter. And then it says, for part 3, construct and label 3 streets that are parallel to one of the streets you just drew. So this is what you're asking. We're going to do this together. We're going to create some parallel streets. So do you guys remember kind of how we started it at least? Maybe I'll do my construction lines in blue. And so the black is like, sometimes what students will do on this is, so sometimes what students will do on this is like do the construction arcs and stuff really light. Like don't do it real dark, and then darken the streets and all the buildings. Okay. So we're going to just kind of, I can't do it light, but I'm going to go ahead and just swing an arc here. Remember how we created our parallel? So from this vertex right here, I'm going to swing an arc here. And if I want to create a few parallel, here, you got to watch this part really carefully. So I'm just swinging an arc from where the 2 streets that I just drew with my straight edge intersect. So pick a distance. And then I'm going to move my compass point, and just out of efficiency, I'm going to swing a couple more arcs here. So there's an arc there. Make sure you go down far enough so that visually it looks like if you drew a parallel line in here, it would actually intersect. So you're going to swing another arc, and then how many streets are we doing? So it's 3 streets parallel to the one that you just drew. I'm going to do another one. So that's going to create 1, 2, and then I need one more up here. So that's what I have so far. I'll move that away. I've got 1, 2, 3, 4 arcs. And I'm going to get 3 parallel streets to the original one out of those 4 arcs. So kind of as you move up, you get the 4 arcs. So, Finley, do you remember, like, this is kind of like the tricky part. Do you remember how we guarantee that those streets are all parallel just using the compass? We've got to measure the gap down here. Remember this gap down here? I need to take this gap down here. I'll move this guy, and I've got to recreate this gap 3 more times. So notice mine's just slightly different than the original gap. It's possible that you guys have the same gap, but highly unlikely, okay? But I've got to slightly change the gap of my compass. Do you guys see that? You barely see it, but this is kind of the part that students get stumped on is, well, how do I figure out what this distance is? And then we have all these streets that are not parallel. I've got to guarantee that these streets are parallel. The way I'm going to do that is by getting just the right gap. Man, I got really close. I could almost get away with what I have here. You see how close that is? I mean, it's super close. But I'm going to just shorten that just a little bit. There. So I'm measuring that gap right there. So you guys are going to have to take your compass and measure that gap right there. Take your compass, put your compass point here. You're going to have to probably change this slider and just change it ever so slightly. Okay. Or maybe a lot. It depends on how far away your original arc was from the vertex. So measure that gap right there. And I've measured it, and then I'm going to go copy that gap 3 times. So I'm going to, while you guys are looking down, just go ahead and measure this gap. If you know how to measure this gap with your compass, did you figure it out? Yeah. Let me know when you've got the gap measured. I don't want you to miss the next part. Got it, Jeremiah? You got that gap measured? Got it. It's like exciting. So it's right across it. So there's our gap. Anybody else need help measuring that gap? Then we're going to copy that gap. And then right here, make that section these maybe a little bit longer. So we can tell where they cross. Hopefully I made mine longer. I almost didn't here. Look at this. So then we're going to copy that gap here. I did better here. Here. And up here. I should have you come up here and demo. Okay, so there, you guys see how I got those 3 crossing arcs? And then when I connect those dots, I should have 3 parallel streets, and I'll label them. And I think we're going to be done for the day. That's the start on this. So I'm going to draw in one of my parallel streets here in black. Oops. Oops. For some reason it's not blocking to the straight edge. For some reason it's not locking down. Anyways, I'm doing the best I can. I don't have an actual straight edge I'm able to use. Okay, so there they are. 1, 2, 3 parallel streets, and then we're going to name them. That's step 4. Actually, that's step 3. Construct and label 3 streets. So I might label this. So I've got Pythag, I got Euclid. I'm going to name this Archimedes. This will be Thales. And then Euler Street. So just label those streets. And then we're going to construct next time at least 2 transversal streets that are perpendicular to the parallel streets. Okay. And then after that, it's mostly just drawing, so I think after we do that on Wednesday, we can finish up. Okay, so bring this back. I need those construction tools passed forward so I can resume with my other class. That's the start of the project.